Good morning, students. This is your Maths 1 online teaching session. Let us continue with our third chapter, that is polynomials, part 6. In the previous session, I have taught you what is value of polynomial. Today we will understand two new concepts. The last two concepts, in fact, of this chapter, remainder theorem and factor theorem. Now, when you divide one polynomial by another, the process can be very long. Now this I have told you what you have learned in 8th standard, the long division method. The process was very long. In order to find a shortcut method, we have these two theorems, the remainder theorem and the factor theorem, which help us avoid this long division process by providing certain rules. Now what rules are there, how it is to be applied, I'll tell you in detail when we will be solving practice set sums. These two theorems help us to find out what is the remainder. Factor theorem help us to find out whether the given divisor is a factor of the dividend or no, in an easy way. Now if I want you to technically understand what is remainder theorem, this is a definition. If the polynomial p of x is divided by x plus a, okay, try to understand. Polynomial is in x, it is divided by x plus a, then the remainder is p of minus a. Now if you substitute x as minus a, whatever you get as value of polynomial, that is nothing but remainder. See, means it is same as the value of the polynomial for x as minus a. Value of polynomial, factor theorem, remainder theorem, all are interrelated. So it is very important that you first understand the concept of value of polynomial, which we have already done. Once you know that, you will understand that when you substitute its value, if it is x plus a, you will substitute x as minus a. If it is x minus a, you will substitute x as plus a. These are the two very important thing to understand. And after substituting whatever value you get, that is nothing but remainder. This is known as remainder theorem. Do not worry at all. You will understand. Let's see with the help of an example. This is practice set 3.5. Divide the first polynomial by the second polynomial and find the remainder. This is important, using remainder theorem. This is what we are learning, okay? X square minus 7x plus 9 is to be divided by x plus 1. Now you are not going to do it by synthetic division. You are not going to do it by long division method. If in exam it is specified find the remainder using remainder theorem, it is strictly to be done by this method only, by remainder theorem method. Okay? Now let's see what are the steps. The first step for such question is always whatever is a given question, you write it as polynomial of x, polynomial of y. Now since look at this question, it is in x square minus 7x plus 9. So I will write it as p of x is equal to x square minus 7x plus 9. It is in polynomial of x. Okay? This is my first step. Then look at the divisor, it is x plus 1. Yes, so exactly the opposite of it as we used to do in synthetic division. Same way, divisor is x plus 1, I will take opposite of this and x as minus 1 I will substitute. I hope you are understanding this concept. Substitute x as minus 1. Therefore by remainder theorem what I will do, wherever I see x I will substitute as minus 1. So this will be p of minus 1. Okay. Now you have learned what is value of polynomial. For x is equal to minus 1, whatever answer you get here, that is remainder. Okay, see how value of polynomial is connected to remainder theorem. I hope you are understanding it. First step, whatever is the given question, you write it as p of x, p of y, p of m, whatever is given. Okay, look at the divisor, it is x plus 1. Exactly the opposite sign you need to take. If it is x minus 1, you will take x as plus 1. Since it is x plus 1, I will take x as minus 1. Substitute it here. Whatever value I get, that is nothing but the remainder. So let's substitute. P of x is equal to x square minus 7x plus 9. I told you x is to be substituted as minus 1. So this will be p of minus 1 is equal to minus 1 the whole square minus 7 into minus 1. Wherever I am seeing x, I am substituting minus 1 plus 9. Minus 1 the whole square is 1, minus into minus is plus, 7 ones is 7, plus 9. Okay, so 1 plus 7 plus 9, what is the answer? 1 plus 7 is 8, 8 plus 9 is 17. I hope you have understood. Try to connect it to the value of polynomial. Now this is actually value of polynomial for x as minus 1, and that is nothing but remainder. Okay, so this way we can find out the remainder using remainder theorem. So this was the first sum. Let us move to the next question. The next question is this: 2x cube minus 2x square plus ax minus a. It is to be divided by x minus a. First step, the variable is x. So we will write p of x is equal to 2x cube minus 2x square plus ax minus a. Next step, look at the divisor. It is x minus a. I hope you have understood. What are you going to substitute the value of x? Exactly the opposite of it. It is minus a. So I will be substituting x as plus a. Okay. So take x is equal to a. And by remainder theorem, what we will get? Wherever I see x now, I will substitute as a. This statement is important and solving it in this way is important. Okay. Since it was x minus a, while substitution what I'll take? Exactly the opposite sign. So x will be equal to a. Substitute it here. Look at this. This is the question given to us, right? So wherever I see x, I will substitute a. So this will be p of a. 2 into x will be a. So a cube minus 2 into x square. So I will write a square plus a from the question itself. X is again a minus a. I hope you are understanding this step. This step, what we are doing, we are substituting x as a. Okay, see what will happen then. This will be 2a cube as it is minus 2a square. A into a will be plus a square minus a. This can be further simplified. Minus 2a square plus a square. What is it? Minus a square. So final answer, remainder is nothing but 2a cube minus a square minus a. It's not different. It's not difficult. I hope everybody is understanding it. What are the basic steps? Whatever is the given question, you write it as p of x. Look at the divisor and you take the sign which is opposite of it. It is minus a, so I am taking a. Substitute it by remainder theorem. Whatever you get the value of the polynomial, that will be the remainder. Okay. So like this, I want you to solve it quickly in your notebook and we move on to the next question. The next question is this: p of m. Okay, 54m cube plus 18m square minus 27m plus 5. Divisor is m minus 3. Do not get afraid of bigger numbers. It is exactly same. Please try it on your own. Okay, p of m is given. Divisor is given as m minus 3. What are you going to take the value of m? That you will substitute here. Exactly the opposite of it. It is minus 3 here. So you will substitute m as 3 in the given equation, in the given polynomial. Okay. So therefore by remainder theorem, p of 3 will be, what is left? Wherever you see m, you are going to substitute 3. So this will be 54 into 3 cube, 18 into 3 square, 27 into 3. Okay. And plus 5. Then m cube. M cube is 3 cube. 3 3s are 9, 9 3s are 27. 27 into 54. Quite a big number you will get. Multiply it and get it. 3 square is 9. 18 into 9. 24 into 3. 27 into 3. Okay. And plus 5. So once I multiply, I get 1458. 1458 plus 162 minus 81 plus 5. So when you add and subtract, you get remainder as 1544. I told you first only, don't get afraid of bigger numbers. You simply have to do multiplication and addition and subtraction. Okay. So what is the remainder in this case? 1544. I hope this method is understood. This sum is understood. All sums are similar for this remainder theorem. Okay. Now what we want to learn is question number 6, which is slightly different from the previous one. Let's see this. If the polynomial y cube minus 5y square plus 7y plus m is divided by y plus 2 and the remainder is 50, find the value of m. Okay. Now what is given in this? What is different actually? Polynomial is given. Divisor is given. Now instead of finding the remainder, they are telling you find the remainder is 50. Okay, then what you have to find? In the given polynomial, you can see a constant m used here. You need to find the value of m. Such type of questions, if you remember, we have also done in value of polynomial. Exactly same type is given here also. Let's see. The polynomial p of y is y cube minus 5y square plus 7y plus m. The given question. What is the divisor? Y plus 2. So what you will take? Exactly the opposite sign. It's plus 2 here. You will take y as minus 2. Substitute it here. Okay. So we will get by remainder theorem. This will become y is minus 2. So this will become p of minus 2. But remainder is how much here? 50. This is the difference. Remainder is 50. It means p of minus 2 is 50. This is what you need to understand in this sum. I hope the concept is clear. Remainder is given as 50. So p of minus 2 will be 50. When I substitute it here, I will get this constant m. Okay. Let's see. P of minus 2. Wherever I see y, I will be substituting minus 2. So minus 2 the whole cube minus 5 as it is. Y is minus 2 the whole square plus 7. Again y is minus 2 and plus m. M we don't know what it is. We need to find out. Minus 2 the whole cube. Cube of a negative number is negative. So it will become minus 8. Minus 2 the whole square is 4. Positive. Okay. 4. 4 into minus 5. That will be minus 20. 7 into minus 2. That will be minus 14. And plus m. Okay. So what we will get? 50 is equal to minus 8, minus 20, minus 14 plus m. Now all these, as you can see, are negative numbers. You need to add it and put minus sign to the answer. 8 and 20 is 28. 28 and 14 is 42. All are minus, so minus 42. Okay. So 50 is equal to minus 42 plus m. Shift it this side, it will become plus. M is nothing but 50 plus 42. Therefore, m is equal to 92. Okay. So I hope you have understood all the steps of this sum. It is straightforward substitution, equating it to 50 and getting the value of m. Okay. Write it fast. We move on to the next question. Next question, in fact, the next concept. It is factor theorem, the last concept of this chapter. It is absolutely easy and similar to remainder theorem. So I am doing it together. You will definitely understand the difference. See this. Factor theorem is a special case of remainder theorem. Now what is the meaning of this statement? Remainder theorem, when I substitute the value, whatever answer I get, that will be remainder. Factor means what? Factor means when I divide another number, a number by some other number, and if remainder is 0, then I can say it's a factor. For example, see, if I ask you, is 2 a factor of 8? What you will do? You will divide 8 by 2, correct? You will get 4 as a quotient and remainder as 0. Since remainder is 0, I can conclude it is a factor of 2 is a factor of 8. Exactly same thing is done here. Remainder theorem states that if the polynomial p of x is divided by a linear binomial x minus a, then the remainder is p of a. This is what we have done in previous slides. Then what is the extension in factor theorem? Factor theorem states that if that p of a is 0, just one step, if that remainder you get 0, then the divisor is a factor of the dividend. I hope you are understanding it. It's just an extension. See, first was value of polynomial, then came remainder theorem. Now factor theorem is just an extension that if remainder is 0, it is a factor of it. Okay. Let's see the sum from the practice set. Use factor theorem to determine whether x plus 3 is a factor of x square plus 2x minus 3 or not. Okay. First step, whatever is a given question, that will be p of x. Now divisor is what? X plus 3. X plus 3. So you will take x as minus 3. It's nothing different. You have to do the steps what you have done for remainder theorem. Remainder will be, by remainder theorem we will get p of minus 3. Okay. So see this, p of minus 3. What will I get? Wherever I see x, I will be substituting minus 3. minus 3 the whole square plus 2 into minus 3 minus 3. Minus minus plus 3 square is 9. 3 2s are 6. Minus 6 and minus 3. Minus 6 minus 3 is nothing but minus 9. 9 minus 9 is 0. In this particular case, I am getting remainder as 0. So I will conclude, since remainder is 0, by factor theorem, the divisor is a factor of the dividend. X plus 3 is a factor of x square plus 2x minus 3. I hope you are understanding it. Remainder theorem, you just have to substitute and leave the answer. Whatever answer you get, you leave it as remainder. Factor theorem is one step ahead. Only if the remainder is 0, then it is a factor. If remainder is not 0, then it is not a factor. For factor theorem, compulsory the remainder should be 0. Otherwise, it is not a factor. If you have understood the previous one, question number 8 is exactly same. If x minus 2 is a factor of this, then find the value of m. Now, it is told that it is a factor. Okay? It is a factor of it. Right? So, given question, p of x cube minus mx square plus 10x minus 20. It's told that x minus 2 is a factor of this. So, what should I substitute? X as exactly the opposite sign, x minus 2 is given. So, I will be substituting x as 2. And it is told in this particular sum that x minus 2 is a factor. It means that when I substitute p of 2, answer I am going to get 0. It is not like the previous one where I had to verify whether it is a factor or not. In this, it's told that it is a factor. I need to get the value of m. Okay. So what I will do? I will substitute x as 2. Okay. So this will be 2 cube, m into 2 square, 10 into 2 minus 20. Now this is what I have got. I know this is a factor. It means here I have to write 0. So I can equate 0 is equal to 8 minus 4m plus 20 minus 20. Okay. 0 is equal to 8 minus 4m plus 20 minus 20. I hope you are understanding it. Why this is written as 0? Because it is told here that x minus 2 is a factor. Since it is a factor, remainder has to be 0. Okay. So when you simplify this further, 20 and minus 20 gets cancelled. 8 minus 4m. So minus 4m can be shifted that side. 4m is equal to 8. M is equal to 2. Now these are the two type of questions that can be asked on factor theorem. First one is to find out whether it is a factor or no. And second one is it's given that it is a factor. You need to find the value of the constant. Okay. So with this, I come to the end of this session. I hope you will remember your homework. What is there? It is just one question, that is question number 9. Using factor theorem in the following examples, determine whether q of x is a factor or no. Now see, it is determine whether it is a factor or no. It is not told that it is a factor. It is determined. So what you will do? It's x minus 1. Exactly the opposite of it. You will take x as 1. Substitute x as 1 in this. If it is equal to 0, it is a factor. If it is not equal to 0, it is not a factor. Same way here, x minus 3. So what you will substitute? X as 3 here. If it is 0, you conclude it is a factor. If it is not 0, it is not a factor. Okay. So I hope you have understood the two very, very important concepts of factor theorem and remainder theorem. Okay. Now, quickly make a note of the omitted sums from practice set 3.5. Sum number 10, 11, 12 and 13 are omitted. So with this, I come to the end of this session. Remaining part of the chapter will continue in the next session. Thank you.